Imagine you are sitting in an AI architecture discussion meeting. Everyone is comfortably talking about temperature, transformer, vector, database, embedding, and other terms. And it seems everyone is comfortable and understand these terms except you. This feeling can be frustrating, but believe me, you are not alone. You may have gone through with several YouTube videos, may have read different articles, or may have used ChatGPT to understand these terms. But when someone asks you what these terms actually means, you struggle to explain them. But here's the good news. These terms are not that difficult if someone can explain you in the simple language. So today in this video, we will break down 25 important AI terms which really required for the day-to-day basis. And we will use the simple Indian analogy and the examples so that you can understand them without any problem. This is part 2 of our AI terminology series. In the part 1, which we released last week, we had covered 18 terms. So by the end of this video, you will completely understand the AI vocabulary which AI consultants, architects, AI engineers use on a day-to-day basis. Now let's begin. The first one is reinforcement learning. You know how we train kids to ride a bicycle. No manual, no PDF. The child falls, gets up, falls again, and slowly the brain learns balance through trial and error. That is reinforcement learning. The AI is not shown correct answers like in normal training. Instead, it tries something and over lakhs of attempts, it learns the best strategy. This is exactly how AI learn to play chess better than humans, or how self-drive car systems learn to brake at the right moment. Trial, error, reward, repeat. Second is fine-tuning. Now imagine you buy a ready-made shirt from a showroom. Good quality, decent fit, but not a perfect fit for your body. So what do? You take it to your local tailor and he makes small adjustments like shoulder tight, short sleeve. Now, same shirt now perfectly fit on you. That's fine tuning. We take a large already trained AI model like GPT and we train it further on a smaller specific data set, say only banking data or only our company's customer support chats. The model does not start from zero. It just gets tailored for your exact use case. And as a solution architect, this is literally 60% of the enterprise AI projects I have worked on. Not building AI from scratch, but fine-tuning an existing model for a client-specific requirement or industry-specific requirements. Next is Transformer. And this is something amazing that will surprise you for sure. Almost every AI tool you use today like ChatGPT, Claude, Gemini, or even Gemini in Gmail is powered by the same technology. It is called the Transformer. Before this, AI used to read text one word at a time, so it often forgot what came earlier. A transformer works differently. It looks at the whole sentence together and understands how all the words are connected. Just like a good teacher who understands the full meaning of a sentence instead of reading one word at a time. This one breakthrough changed AI forever and made today's powerful AI tool possible. And how does transformer knows which words matter? Through something called as attention. Think of a mother in the kitchen cooking while 3 kids are shouting in the next room. She's not processing every single sound equally. Her brain automatically gives more attention to the one voice that says, "Mama, I got hurt," and ignores the regular playing noise. Attention mechanism does the same for AI. Out of 100 words in your sentence, it decides which words deserve more focus to understand the true meaning. That is why AI doesn't get confused by long, complicated sentences anymore. Next is parameters. I'm sure you must have heard this model has 175 billion parameters. What does that actually mean? Think of your grandmother making the perfect sambar. She doesn't measure everything exactly. She keeps making small adjustments, adding a little more turmeric, a little more chili, a bit more cumin until the taste is just right. AI learns in a similar way. Instead of spices, it has billions of teeny settings called as parameters. During training, these settings are adjusted again and again until the model learns to give better answers. But bigger is not always better. That's a myth I may bust in another video. Sixth is context window. Have you noticed if you chat too long with ChatGPT, it suddenly starts forgetting things what you said at the beginning? That is because of the context window. Think of it like a whiteboard in a small meeting room. You keep writing on it, but the board has a limited space. Once it is full to write new points, you have to erase the old ones. Context window is literally the amount of text measured in tokens. Remember those from part 1, raw tokens you must have remembered, that an AI can hold in its head during one conversation. GPT-4 has a bigger whiteboard than other models. That is why longer conversations don't break down as easily nowadays. Okay, this next term actually separates a casual user from someone who actually knows how to control AI output. temperature. When you order chai from two different tapriwalas, one makes it exact same way every single time, predictable, safe, consistent. The other one experiments, at times elaichi, at times cinnamon, at times extra adrak. Every cup is a little different. Something amazing, sometimes not. That difference, that is called temperature in AI. Low temperature equal to safe, predictable, same kind of answer. And high temperature means creative, varied, sometimes surprising answers. When I need factual, business critical output for a client, I keep temperature low. When I want creative marketing copy, I push it higher. Imagine a new driver giving the keys to a brand new car model he never driven before. If he can drive it well without any practice, just based on general driving knowledge, that is zero short learning. The AI platform tasked with zero example given. Now, if you show him 2-3 quick demos first and then he drives confidently, that's few short learning. You give AI a few example in your prompt, then it picks up the pattern instantly. That is why in my prompts I often say, here are two examples of how I want the email written. Now write the third one. That is the few short prompting in action. And here comes chain of thoughts. Remember class 10th math exams? Teacher always had asked, show me the calculation, show me the steps, don't just show me the final answers. Because when you show the steps, the chances are of a silly mistake will go down and it's easier to verify. Chain of thoughts is when we ask AI to think step by step before giving the final answer, instead of jumping directly to a conclusion. This dramatically improves the accuracy, specifically for logical and mathematical problems. Next time you're stuck with a wrong AI answer, just add think step by step in your prompt. Try it. It works like magic. 10th is multimodal AI. Think of it as a typical family WhatsApp group. Someone sends a text message, someone sends a photo of a dish, someone sends a voice note complaining about traffic, and everyone in the family understands the full picture, combining all three. Multimodal AI works the same way. It can understand and process text, image, audio, and video together, not just one type only. That is how you can now show ChatGPT a photo of your fridge and ask, what can I cook tonight? It sees the image and reads your text questions together. That's multimodal AI. Imagine your housing society security guard sitting at the gate and watching the CCTV screen. He's recognizing which car belongs to which flat, which face is a regular resident and which one is a stranger. Now, computer vision is the branch of AI that gives the same power to the machines to see, recognize, and understand images and videos. This is also what powers the face unlock on your phone and traffic challan cameras that read your number plates automatically. Next is overfitting. And this is like personal experience I'm sharing. Early in my career, my team built an AI model to predict which telecom customers might leave. During testing, it showed 98% accuracy and we were excited. But when we used it with the real customers, it performed very poor. Why? Because the model had simply memorized the training data instead of learning the real patterns. It's like a student who memorized last year's exam paper but cannot answer new questions in the actual exam. This is called overfitting. We spent nearly 3 weeks fixing the model and I never forget that lesson. Here I would like to take a quick pause and just want to check with you, are you enjoying this video? Are these real life examples having a better understanding than those boring definitions of these terms? If yes, please hit the like button, and if you have not already subscribed, please subscribe to AI Catalyst because I'm planning for the third part of this series. Now let us resume to the next 13 terms. 13th is AI bias. If you have trained an cricket commentary AI using the commentary data only from North India matches, it might completely misunderstand the terms and phrases common in Chennai or Kerala stadiums. That is AI bias. When the training data itself is unbalanced or unrepresentative, the AI decisions reflect that imbalance. I have seen this practically. A loan approval AI trained mostly on the urban applicant data started undervaluing genuine rural applications because simply it had never seen few of them. This is why responsible AI teams work so hard on balanced, diverse data sets. The 14th is compute, about GPU and TPUs. I'm sure you must have heard CPUs at the earlier, like normal computer processor unit. So this is like a smart clerk who can handle one request at a time. A GPU is like 1,000 of clerks working in parallel simultaneously. AI training needs this massive parallel power, and that is why GPUs and at times specialized chips which are called TPUs are real expensive engines running behind the every AI model you use. You can think of like IRCTC Tatkal booking at 10 a.m. Lakhs of people click book at the exact same second. To handle that kind of dynamic power, we need a lot of CPU, GPUs, and the TPUs at the time. Next is API. I mean, you don't walk into a restaurant kitchen to get your food. You tell the waiter to what you want, and the waiter brings it from the kitchen to your table. An API is exactly this waiter, a bridge between your app talk to an AI model without needing AI to know what's happening inside. When Swiggy chatbot answers your queries, it's talking to an AI model through an API behind the scenes. Open source versus closed source. One YouTube chef shares his entire recipe, ingredients, and method for free. Anyone can cook it, tweak it, even sell it. Another top restaurant guards its recipe like a secret. You can only order and eat the dish, never get the formula. That is open source versus closed source. Meta's Llama or DeepSeek are largely open. Anyone can download and modify these models. GPT-4, Gemini, Claude, this is closed source where you can only access them through their official app or API. Their recipes log. Next is guardrails. Speed breakers, traffic signals, road dividers. They don't stop you from driving. They just keep you within the safe limits. Guardrails are the safety rules and filters built into AI systems, preventing it from generating harmful, unsafe, or inappropriate content. Even if a user tries to push it that way, every serious enterprise AI deployment I have architecture include multiple layers of guardrails before it ever reaches the customer. Prompt engineering. I mean, when you go to an Indian restaurant and you say, give me some good food, you might get anything. But if you say medium spicy paneer butter masala, less oily, extra gravy, you get exactly what you wanted. Prompt engineering is that same skill, the art of writing clear, specific instructions to get the exact output you want from AI. As a solution architect, I have seen this become an actual paid skill in the job listing nowadays, because the difference between a vague prompt and a well-engineered one is the difference between a useless answer and a brilliant one answer. By the way, I have a dedicated prompt engineering series on my channel AI Catalyst. You may want to watch it later after this video. Vector database is like a library where books are not arranged alphabetically but by the meaning and similarity. Like all the books related to cooking are sitting together, regardless of the author's name starting with A or Z. A vector database actually stores information in this meaning-based way, so that when AI needs to find related information like rag, it can instantly pull the most relevant content, not just the random keyword match. Diffusion models like jigsaw puzzle. At first, all you have is a pile of random pieces. You can't tell what the final picture will look like. But as you place the right pieces one by one, the picture slowly becomes clear. Diffusion models work in similar way. They start with random noise and gradually removes it step by step until a clear image appears. So 21st is interesting one, the Edge AI. It's like a local kirana store which can fulfill your order within 2 minutes. But if you will order the same item from a faraway warehouse, it will take 2 days. Edge AI is the same thing running on your device, on your phone, your smart camera. So instead of sending data all the way to a cloud server and back, it is why your phone's face unlock works instantly, even in a flight mode with no internet. So that kirana store is right there on your device. So that is like a local AI called as Edge AI. Next is synthetic data. So before your board exams, your teacher gives you mock test papers, right? Not the real question papers, because those are not available yet, but artificially created ones designed to be a realistic practice. Synthetic data is exactly this, artificially generated data used to train AI models when real data is limited, expensive, or not available, or maybe private, like some patient's health record. Imagine if a bank manager rejects your loan application and just say no. You would frustrate. But if he explained your credit score is low because of these two specific reasons, you at least understand the decision. Explainable AI is the push to make AI models transparent about why they've made a certain decision instead of being a mysterious black box. This is critical in banking, healthcare, and hiring industries where I have personally had to justify AI decisions to the compliance teams at times. A mother can sense her child's mood from just one word on the phone, fine. She instantly knows something is not fine, right? Sentiment analysis is the AI reading the text like thousands of Zomato or Amazon reviews and detecting whether the emotions behind it is positive, negative, or neutral. Companies use this at scale to understand customer moods without reading every single review manually. Here comes the last one, the digital twins. If you know, before any big Bollywood dance sequence is shot, there's always a full dress rehearsal, testing the lights, costume, choreography without spending the real shooting budget. A digital twin is a virtual living replica of the real physical system. A factory, a machine, even a city's entire traffic network used to simulate and test changes safely before applying them in the real world. Indian manufacturing plants and even in Indian railways are now experimenting with digital twins to predict the failures before they really happen in the real life. So my friend, these are the 25 AI terms we learned today, from reinforcement learning to digital twin. What I want you to do right now, please Let me in the comments which AI terms you finally understood and now it makes sense to you better than earlier. I would like to read all of them, which will really encourage me to make the part 3 of this video. Also, if part 1 and part 2 together help you to understand even slightly about those AI terms, please hit the subscribe button and share it with one of your friends who is still confused about AI terms. This is Upadhyay and this is AI Catalyst. I'm signing off for now. Keep learning, keep building. See you in the next one very soon.